So I'm going to explain about the meaning of second order linear differential equation. All right? So you have to fully understand what the second order means, right? And what's the difference between second order and first order, because you already know, first order. And you have to thoroughly understand the linearity, the characteristics of the linear system. Okay, that's very important. That's two basic fundamental concept. All right. For second order versus first order. On first order, you have the solution y is a function of a function, right? Y1 could be any function in its primitive form, right? And you multiply by the constant, right? Arbitrary constant. And that's the form of the solution for first order, right? Y1 is a function that solves the differential equation, right? And you generalize that solution using this arbitrary constant, so that you have the full general solution for the given differential equation, right? But now, what about in second order? For second order, what could be your guess? The natural extension of this is you could have y1 and y2. That solves the given differential equation, right? Then you could write that way. Is it quite reasonable to you? If I write that way, the solution y for the second order differential equation should be some function that solves the equation and another function that solves the equation, and you linearly combine those using arbitrary constant. Okay? That seems to be reasonable, right? Because we are, expanding the same fundamental concept to the second order, another dimension, right? And let's see. So we have two things here, okay? One is basis. Is this y1, y2 any function? It should be very special function, right? Of course. I mean, there could be hundreds or thousands of functions that can satisfy the given differential equations, right? But they are very similar. They could be very similar, right? But we don't need the similar, solutions all the time. So this y1 and y2 is very special function, not just any function that satisfies differential equation, but very special function, okay? That's called basis. So we have to find the basis y1 and y2. Okay? And secondly, linear combination. Meaning C1 times plus C2. That's a linear combination, right? You have y1 and y2, and you linearly combine them, meaning, you multiply arbitrary constant to each function and then add them up. That's a linear combination. Okay? In a more, fancier word, we call it superposition rule. Superposition rule. Okay? Superposition rule, you know that, right? This is, let's say, y1. This is y2. y1 plus y2 is, you add them up like that, right? That's a superposition rule. For the linear solution, if you add them up, that's also linear, right? This is very fundamental, very important rule. This is only valid in linear system. If it's a nonlinear system, you cannot assume this. Okay? So we have to first, identify the basis, right? y1 and y2 is not just any functions, but it's a special. It should be special functions, okay, that form a basis, okay. And to be a basis, y1 and y2 has to be linearly independent with each other. I'm going to explain, the meaning of linearly, independence, but y1 and y2 has to be linearly independent with each other. Okay, that's the true meaning of this. And you have to, figure out the linear combination, the real meaning of linear combination, that is C1 plus C2 times Y2. That's the meaning of linear combination, and that's called superposition rule, and it's a very important property of the linear system. Okay? If it's a nonlinear system, you cannot do anything. You cannot have the same, principle. You cannot use that, right? Then it's a totally different thing, okay? Right? For nonlinear system, this one won't work. You have to invent a new methodology or method, okay? It's a totally different stuff. So, all right. So linearly, wow, independent of y1 and y2. What is that? What does that mean, really? Okay? Then you have to first understand, then what is linear dependent? Okay? Let me visualize it. If y1 and y2 function are linearly dependent, this is what's going to happen. This is a linear, okay? I'm just visualizing a linear function, okay? Let's say y1 is this, and linearly dependent is this state. Okay? If they are really collinear, we call it also collinear. Meaning it has slope, has the same slope. Okay? As long as it has the same slope, they are collinear and they are linearly dependent. You get the feeling of the words, right? Linearly dependent. They are linearly the same, right? So that's the meaning of linear dependent. Okay? Linearly dependent or linear dependency. Linear dependence. Okay? And if you, expand the same concept to linearly independent, okay? The y1 and y2 should have different slope, right? Okay? Then, let's say this is y2. Then y1 has to be like that. Okay? That's the linear independent. The concept of linear independent. So basis, to be a basis, y1 and y2, special y1 and y2, they have to be at least linearly independent. They should have different slope. Okay? Okay, so I explained the most basic stuff of a second order differential equation, and the one thing I didn't mention is initial value problem on second order. Okay, on first order, the initial condition was this, right? Right, at some point x0, and if you have a value of y of 0, And that's the initial value condition. And that really judges the particular solution out of the most general solutions, right? Family of solutions. You particularly, specify out of this general solution with the given initial value. Here, let's say, x naught, y naught. You're specifying the particular solution out of that many family of solutions. Okay? That's the meaning of initial value. Right? For second order, you need y is c1, y1 plus c2, y2. You have two unknowns, right? Then you need two conditions. Okay? Then what about this? y1, x naught 1, y naught 1. y2, x naught 2, y naught 2. That makes you complicated? I don't know. You see that meaning, right? You have two different initial conditions. Then you're going to get C1 and C2. But unfortunately not. Because it's initial condition, right? If you have this, that means somewhere here, right? Somewhere on the solution that's already been chosen. In that case, C is the same. You won't have the different C. So you should have, this is not, you should have y x naught 1 prime. Okay? That's the initial condition for the second order system.